So now we're going to take everything we learned with substitution, addition method, and graphing and put it all within applications of linear systems. Here's the summary, how to solve or using the methods to solve systems of linear equations. So example number 1, a metal worker has some ingots of metal alloy that are 20% copper and others that are 60% copper. How many kilograms of each type of ingot should the metal worker combine to create 80 kilograms of 52% copper alloy? Now you're probably thinking, what is this even asking me? First of all, you don't even need to know what an ingot is. But what do you need to find? How many kilograms of each type of ingot? So we have two kinds here. Copper, the mass of 20% alloy, and the mass of 60% alloy. We want to know, once again, if you look at this, how many kilograms? That's weight. So the mass of 20% copper and the mass of 60% copper, or alloy. So, if it helps you, you can write first what you need to find. So G, I'm going to say mass of 20% alloy, and H is going to be 60%. So what do we know first? We have to have a total of 80 kilograms. So that should be pretty easy to set up. G plus H, because remember, each of those represent the mass. So the mass of G plus the mass of H would have to give me a total mass of 80. Now, percents always have to be written as decimals. So we know the 20% copper, which is 0.2 G, plus 0.6 H, would have to give me what? 52% of the 80. So we'd have to take 52% of 80. So that gives me what? Well, that gives me the equations G plus H equals 80 and point G plus 0.6 H equals what? Well, what's 80 times 0.52? That gives me 41.6. Now, you can actually use whatever method you want. Now, most people, hardly anyone ever picks graphing. I look at this and go, it's already lined up. So I can multiply the G by like negative 0.2 to get rid of the G's, or I can multiply the H by, let's say, negative 0.6 and get rid of the H's. What do we want to do? I'm going to use substitution. That sounds good. So the first thing I'm going to do, I'm going to solve the first equation for G. So I'm going to do G equals, and then 80 minus H. So I'm going to take what G is equal to and plug it in right here. That would give me 0.2 times 80 minus H plus 0.6 H equals 41.6. So 0.2 times 80, that gives me 16 minus 0.2 H plus 0.6 H equals 41.6. I'm going to move up here since I ran out of room. So negative 0.2 H plus 0.6 H, that gives me 0.4 H. I'm going to subtract the 16 on the other side. That gives me 25.6. I divide by 0.4. That gives me H is 64. So what does that mean? Well, H was 60%. So what's the mass? Well, the mass would be, I have 64 kilograms of 60% alloy. So what do I know? I have a total of 80. If I have a total of 80, that means the other is going to be 16 kilograms of the 20% alloy. All right, you don't need to write this part down, just watch. When starting a business, people want to know the break-even point. So that's kind of a vocab word. A break-even point is a point at which their income equals their expenses. Think of it this way. If you're opening a Jimmy John's restaurant, you would have to pay all of this money to build the restaurant, hire employees, buy food, buy equipment, build your building. The break-even point is when you gain your expenditures back. So the graph at the right shows the break-even point for a business. You'll notice the break-even point, the red is expenses. So we start off with quite a bit of expenses, and then they start making money. Everything in the white is where they've lost money. Once you hit the break-even point, you hit zero. Anything after that, you make money. Notice that the values of Y on the red line represent dollars spent on expenses, and the values of Y on the blue line represent dollars received in income. So Y is used to represent both income and expenses. Example number 2, let's find a break-even point. Suppose a model airplane club publishes a newsletter. Expenses are 90 cents per printing and mailing each copy, plus $600 total for research and writing. The price of the newsletter is $1.50 per copy. How many copies of the newsletter must the club sell to break even? So what are we trying to find? How many copies of the newsletter must the club sell to break even? So X, I'm going to let be the number of copies, because we don't know that. Y, now remember, this is the amount of dollars. This is going to be dollars. Now that could be representations, that could represent expenses or income. So let's set this up. What are our expenses? Our expenses are 90 cents for printing per copy, but we don't know what that is. So it's per copy plus $600. That equals what? That equals our expenses. Remember, Y can be expenses or income. So in this case, Y represents our expenses. What's our expense? This entire thing is on expenses. 90 cents per copy plus $600. Now income is what? Y equals $1.50 per copy. Well, that's just going to be 1.5x. So I have my two equations as Y equals 0.90x or 0.9x plus 600, and Y equals 1.5x. How do I solve this? Well, I'm obviously going to substitute because I already have both equations solved for Y. So I'm going to take the second equation, Y equals 1.5x, and I'm going to plug it in. That gives me 1.5x equals 0.90x plus 600. I subtract 0.9, that gives me 6/10 or 0.6x equals 600. I divide both sides by 0.6 and I get 1,000. So what does that mean? How many copies of the newsletter must the club sell? They must sell 1,000 copies. Now, if it asks you, well, how much would they have to, what would their break-even money amount be? After 1,000 copies, you could take the 1,000, just plug it into either one of these. 1,000 times 1.5 would be $1,500. So they would have to eventually break even once they brought in $1,500. But 100 copies would be your answer. All right, and you guys had so much fun on this back in Chapter 3. It's back again. In Lesson 3.6, you modeled rate, time, distance problems. Remember, that was D equals R times T. Distance equals rate times time. But you only used one variable. You can also model rate, time, distance problems using two variables. The steady west to east winds across the United States acts as tailwinds for planes traveling from west to east. The tailwinds increase, so remember once again, if you're going with the wind, it increases your speed. If you go called headwinds or against the wind, that decreases your speed. So if you're looking here, the total ground speed, if you're going from west to east, it increases. So you take how fast you're going plus the wind. I mean, think of it this way. If the plane's going 50 miles an hour and the wind's 5 miles an hour and you're going with it, it increases you by 5. So you're going 55. So you take 50, which is what your plane is going, plus the 5, which is what the wind is going. That's 55 miles an hour. But if you're going against it, instead of 50 miles an hour, you subtract it. So you'd actually be going 45 miles an hour. So example 3. This is a fun one. Suppose you fly from Miami, Florida to San Francisco, California. It takes 6.5 hours to fly 2,600 miles against the wind. At the same time, your friend flies from San Francisco to Miami. Her plane travels at the same average airspeed, but her flight only takes 5.2 hours. Find the average airspeed of the planes. Find the average wind speed. So, in this problem, what I would do, now it's completely up to you what you want to do, but here's how I set these up. This is only for motion problems. And we kind of did this before. Distance equals rate times time. So we know what? We are going with the wind and we are going against the wind. So let's figure out what we know. We know it takes 6.5 hours to fly against the wind. So I can plug in 6.5 for the time. It takes 5.2 hours to go with the wind. Her plane travels at the same average speed. So we don't know what the rate is. Remember, rate is speed. So we don't know what it is. So I'm going to let that just be R. Same average speed. But if you are going against the wind means you are subtracting. It's making you slower. So against the wind means we're subtracting the wind speed. With the wind means we're adding the wind speed. Now, what's the distance? Well, the distance either way is the same. So the distance is going to be 2,600. And now we set up our equations. 2,600 equals 5.2 times R plus W, and 2,600 equals 6.5 times R minus W. Now, in this case, you could distribute the 5.2 and the 6.5 and then figure out what you want to do from there. But remember, there's a shortcut. You can actually get rid of the times 5.2 first by dividing both sides by 5.2. You can get rid of the times 6.5 by dividing both sides by 6.5. So let's do that. That would give me it would not give you 2,600. If you divided both sides by 5.2, you would get 500 equals R plus W. If you divided both sides by 6.5, you would get 400 equals R minus W. Notice that everything is already lined up. The second thing you notice is that something cancels. The W's are going to cancel. Let's just add these together. So I'm going to get 900 equals 2R. So R equals 450. What does that mean? R represents the rate or the speed of the plane. So what's the average airspeed of the plane? The plane goes 450 miles per hour. So what's the wind speed? Well, let's plug it in. So I'm going to take the 450 and I find out, okay, what would be the easiest equation to plug in? Well, I'm just going to plug it in right here. 450 plus wind equals 500. Well, that's easy. 500 equals 450 plus W. Well, I just subtract 450. That means the wind, either direction, is 50 miles per hour. So the wind is 50 miles per hour. The plane traveled 450 miles per hour.